Okay, let us continue the remaining numerical of solutions. I have discussed molarity, mole fraction, Raoult's law, Henry's law. Now let us move on to the next part, that is colligative property. You are familiar with the word colligative property. What is colligative property? The property which depend upon the number of solute particles present in a solution. There are four colligative properties: relative lowering of vapor pressure, elevation of boiling point, depression of freezing point, and osmotic pressure. So now we are going to discuss numerical on the basis of these four colligative property. Okay. The first colligative property is relative lowering of vapor pressure. Now here is the first numerical on relative lowering of vapor pressure. You read the numerical. Vapor pressure of pure water at 298 Kelvin is 23.8 mmHg of urea is dissolved in 850 gram of water. Calculate the vapor pressure of water for this solution and its relative lowering. Now you have to calculate what vapor pressure and its relative lowering. Okay, now let us see. Let us do this. Here that word, what amount of urea missing is missing. Vapor pressure of water at this, calculate the vapor pressure of water when 25 gram of glucose is dissolved in 450 gram of water. Now let us solve it. Vapor pressure of water P minus PS, vapor pressure of solution, upon P is equal to WA MB MA upon WB. This is the formula for RLBP. Vapor pressure of water is given, this value is given 17.535. Calculate the vapor pressure of solution. Now 17.535 minus PS upon 17.535 is equal to WA. What is WA? Glucose 25. You know molar mass of water, it is 18. Molar mass of glucose, it is 180, dissolved in 450 gram of water. So each and everything is given. You have to calculate vapor pressure of solution. Okay, solve it. 18 1 jar, 18 10 jar, 5 jar, 5 2 jar, 5 1 jar, 5 9 jar, 90. Now this comes to be 17.53 minus PS upon 17.535 is equal to 1 upon 180. Here now 17.535 minus PS upon 17.535 is equal to 1 upon 180. Let us divide it and see what is coming. 1 divided by 180, it is 0.0055. 0.0055. Clear? Now, you cross multiply 17.535 minus PS is equal to 17.535 multiplied by 0.005. Okay, you multiply 17.735 minus PS is equal to how much? Let us multiply. We will get how much? 17.535 multiplied by 0.005. This is equal to 0.087. 0.087. Therefore, PS, vapor pressure of solution, will be equal to 17.535 minus 0.087. You subtract it, you will get the answer 17.438 mmHg. Now you see, this is the vapor pressure of solution, and vapor pressure of solution is always less than vapor pressure of pure solvent. Okay, this is how the properties RLVP, relative lowering of vapor pressure. Clear? Understood? Now let us move on to next numerical. Next part, let us see. Now this is important numerical. A solution containing 30 gram of non-volatile solute. Read over here, there are two parts. 30 gram of non-volatile solute, 90 gram of water has vapor pressure of this. This is part 1, this is part 2. Okay, we have to calculate two parts. First is molar mass, second is vapor pressure. There are two parts of this. A solution containing 30 gram, this is case first. Let us solve case first. Case first. A solution containing 30 gram of non-volatile solute. 30 gram of non-volatile solute means WA. Molar mass of solute is equal to 30 gram. Okay. In 90 gram of water, that is WB. This is 90 gram of water. Has vapor pressure. Vapor pressure is given. This is vapor pressure of solution, and this is equal to 2.8 kilopascal. Clear? Then we have to calculate molar mass. Suppose this molar mass is unknown. You apply the formula P minus PS upon P is equal to WA MB upon molar mass of solute. We have to let it be M multiplied by WB. 1 minus vapor pressure is 2.8. 2.8 upon P is equal to, we can just write P minus, first you write this P minus this upon this. WA is 30, this is 90, sorry, how it can be 90? This is molar mass of water 18 upon, and you have to calculate WB is given 90. 18 1 ja, 18 5 ja, 5 1 ja, 5 6 ja. Or this comes to be P minus 2.8 upon P is equal to 6 upon M. Clear? Or we can write 2.8 upon P will be equal to 1 minus M upon 6. Solve it. This will be 2.8 upon P will be equal to what? What did I? Wait a minute. 1 minus 6 upon m. When you solve it, this is m minus 6 upon m. This is equation number 1. From first part, this is case 1. Similarly, let us solve case 2. Where is case 2? Case 2 I am writing over here. Case 2. For case 2, 18 gram of water is added. Meaning WA is remaining same. WA is equal to 30. 18 gram of water is added. So this W will become how much? 108. PS, solution vapor pressure becomes how much? 2.9 kilopascal. And this molar mass of solute you have to calculate. Similarly, you make another equation from that case 2. What we will get? P minus PS upon P will be equal to 30 into 18 upon M into 108. So 18 1 ja, 18 6 ja, 6 1 ja, 6 5 ja. So this is P minus 2.9 upon P is equal to what? 5 upon M. Okay, so we can write 2.9 upon P is equal to 1 minus 5 upon M. You solve it. 2.9 upon P will be equal to M minus 5 upon M. This is equation number 2. Two equation. There are two parts, case 1 and case 2. I have solved both the parts. This is part 1, this is part 2. Now from this we can solve remaining part. Okay, how? Let us see this. Dividing 1 by 2, you divide equation 1 by 2. Divided, you will get what? 2.8 upon P will be equal to M minus 6 upon M divided by 2.9 upon P is equal to M minus 5 upon N. P cancelled. What is left? 2.8 upon 2.9 is equal to M minus 6, M minus 5. Now you cross multiply this. On cross multiplying we will get 2.8 M minus 5 will be equal to 2.9 M minus 6. Multiply it. This is coming to be 2.8 M minus 5 8 ja 8 5 ja 44. It is 14. This comes to be 2.9 M minus 6 9 ja 54 5 17.4. Okay, let us solve it over here. Or we will get 2.8 M minus 2.9 M is equal to minus 17.4 plus 14. You will get the answer. This is minus 0.1 M. is equal to minus 3.4. Minus minus get cancelled. M. Molar mass we have got 34 gram per mole. First part is over. So, calculate molar mass. This we have calculated. Now what is left? Vapor pressure of water. You put this in any equation, putting the value of M. Value of M in equation 1. Let us put in equation 1. You put it in equation 1. What is equation 1? Where I have it in equation 1? You can write over there 2.8 is equal to M minus 6. Instead of M, we will write what? 34 and you will get the answer. Yes or no? We have to calculate what? Vapor pressure here. From here you can get what is required. Now you put the value of M in this. So we will get 2.8 upon V is equal to M. What is M? 34 minus 6 upon 34. You solve it, you will get the answer. 2.8 upon V is equal to 34 minus 6. It is 28 upon 34. You cross multiply it, you will get the answer. Let us do it. Into 34 is equal to 28 into P. This is vapor pressure. Therefore, this P will be equal to 2.8 into 34 upon 28. Okay, solve it. Point 1. This comes to be 3.4 kilopascal. Problem in the pen. 3.4 kilopascal. This is the vapor pressure, pure vapor pressure of water. This is how this numerical is calculated. Okay. Understood? Now let us move on to the next numerical, next qualitative property. (18 gram of glucose molar mass is dissolved in 1 kg of water in a saucepan. At what temperature will the solution boil? Kb is given, boiling point is given, 18 gram of glucose. Now let us solve. 18 gram means mass of solute, and Wa is equal to 18 gram. Is dissolved in molar mass of glucose. Molar mass of solute is also given, 180. This glucose is dissolved in 1 kg of water. 1 kg of water. And Wb is 1 kg, or we write 1000 gram. What we get at what temperature? So Kb is given, constant Kb. That is boiling point elevation constant 0.52 Kelvin per mole. We have to calculate boiling point of pure water. Therefore, you know this, delta Tb is equal to Kb into Wa into 1000 upon Na into Wb. First we will calculate this molar elevation constant. Delta Tb is equal to 0.52 into Wa. Where is Wa? 18 into 1000 upon 180. It is molar mass into mass of water 1000 gram. 1000, 1000, 18 1 ja, 18 10 ja. We divide it, we will get delta Tb. So delta Tb comes to be 0.052 Kelvin. Okay, now you have to calculate what? Boiling point. Therefore, boiling point of solution is equal to boiling point of water plus delta TB. Now what is boiling point of water? It is given 317.15 plus what is delta elevation? Boiling point is increased. You have to add the delta TB added 0.052. You will get the answer. And what is coming in? What is the answer of this? 373 point you added 202 Kelvin. This is the answer for this question. Understood? It is a very simple question. We have to calculate boiling point of solution. Clear? Now let us move on to our next part. Next question, question number 18. Some of the questions are very simple. Now this is next question for you. Question number 18. On dissolving 3.24 gram of sulfur in 40 gram of benzene, boiling point of solution was higher than that of benzene. What is the molecular formula of sulfur? Dissolving 3 point given. Wa is equal to 3.24 gram sulfur in 40 gram of benzene yani Wb solvent 40 gram. The boiling point of solution is higher benzene by this, and this is delta Tb. This is the elevation 0.81 Kelvin. Okay, Kb of benzene is given. It is 2.53 Kelvin per mole. What is the molecular formula of sulfur? First we will calculate molecular mass. Therefore, you know this formula. Delta Tb is equal to Kb into Wa 1000 upon molar mass into Wb. First, we have to calculate molar mass of solute. Therefore, Ma will be equal to what? Molar mass will be equal to delta Tb is given 0.81 into Wb 40. Now you solve it. This is point to remove this point 120. This cut off 4 8 ja 4 1 ja. Okay, 81 cancelled. We get molar mass. It is 253 gram. Molar mass is this. But we have to calculate what? Molecular formula. Now you know. Let number of molecular formula. Let us write molecular formula. That is simple way. Let molecular formula of sulfur is equal to Sx. X is number of atom. Atomic mass is given. You know, atomic mass of sulfur is 32. Yes or no? Therefore, molecular formula will be equal to what? 32 into X. Just we have calculated 253. So molecular formula mass 253 is equal to 32 into X. You calculate X. X is equal to 253 upon 32. Approximately this X comes to be 8. Approximate value. Therefore, molecular formula is equal to S8. What is the molecular formula of sulfur? It is S8. Understood? Clear? We have to calculate molecular mass. From that molecular mass, we can calculate molecular formula. Clear? Now let us move on to next numerical. This. A 5% solution by mass of cane sugar in water has freezing point of 271. Calculate the freezing point of 5% glucose in water. The freezing point of pure water is. There are two cases. One is this and another is this. Two cases. Let us frame first case. Case 1. Solve one by one. Case first. 5% of mass of cane sugar means 5 gram. WA is equal to 5 gram. Cane sugar, molar of cane sugar, yani MA, molar mass of cane sugar is 342. Cane sugar, you know, C12H2211, 12 into 12 plus 22 into C12H into 1 plus 11 into 16. You will get this. Freezing point of water is given. This is case first. Calculate the freezing point of 5% glucose in water. The freezing point of pure water is this. Then from here we will calculate delta. Freezing point TF is equal to 273.15 minus 271, and this is coming to be 2.15 Kelvin. This is for cane sugar. Okay, case 1. I am writing here for cane sugar. Cane sugar is sucrose. Then you make the formula for cane sugar. Delta TF is equal to KF into, you know the formula. You apply the formula for cane sugar, 1000 MA into WB. Delta TF we have calculated. 2.15 is equal to KF into WA, 5 gram into 1000 upon molar mass 342 into WB. Solute, it is 95. Yes or no? Solvent mass 100. My total is 100. 100 minus 5 is this. This is equation number 1. Okay, similarly, you frame the same equation for glucose, case 2. Here I am writing case 2. Okay, glucose, this is case 2 is for glucose. Glucose. 5 gram of glucose is 5% means 5 gram of glucose is present in 100 gram of solution. So what is the mass of solvent? 95. WA is this. Molar mass of glucose, you know. Molar mass of glucose is 180. We have to calculate delta TF. Write the formula. Delta TF is equal to KF into 5 into 1000 upon 180 into 95. This is our case 2. Yes or no? We have written simultaneously both. This is for glucose, cane sugar. This is for glucose. Okay, now divide. Here I am writing divide 1 by 2. You divide equation 1 by 2. What you are going to get? You will write directly 1 by 2. 2.15 upon delta TF will be equal to KF 5095. So all will get cancelled. Clear? So 2.15 on delta TF this divided by this. This will be equal to what? 180 upon 342. Now you solve it. Therefore, delta TF is equal to how much? 2.15 into 342 upon 180. You solve it, you will get delta TF. and this comes to be, let me solve it. What is coming? 2.15 multiplied by 342 divided by 180, 4.08 Kelvin. 4.08 Kelvin. We have to calculate freezing point of glucose solution. Now you can calculate freezing point here. Let us solve it. Freezing point of a solution will always be less than freezing point of what? Pure water. Therefore, freezing point of glucose solution is equal to, freezing point of water is given 73.15 minus delta TF 4.08. You solve it, you will get the answer 269.07 Kelvin. This is the freezing point of glucose. This was the freezing point of solution of glucose. 269.07 Kelvin. Understood? Clear? Now let us move on to next numerical. Now this is a very big numerical. Two element A and B form compound having molecular formula AB2. Now for AB2, let us solve. I am making two part over here. For AB2, okay, and here for AB4. For AB4, you read, when dissolved in 20 gram of benzene, 1 gram of AB2, WA. For AB2, WA is equal to 1 gram. Lower the freezing point, yani lower the freezing point, delta TF is equal to 2.3 Kelvin. 20 gram of benzene, this is WB, this is 20 gram. Similarly for AB4, what is W? 1 gram. WA is equal to 1 gram, and lowering of freezing point, delta TF is equal to 1.3 Kelvin. TF value is given. Okay, therefore, for AB2 we know delta TF, we will calculate molar mass of solute, WA into 1000 upon MA into WB. You have to calculate molar mass, and A, molar mass of solute will be equal to KF. What is the value of KF? 5.1. 5.1 multiplied by 1 into 1000 upon delta TF 2.3 upon benzene 20 gram. Solve it. Point 0, 0. 2 1s are 2 5s are 50. All this is 51 into 50 upon 23. Let us solve it. What is this? It is coming to be 51 into 50 divided by 23. 110.86. This is 110.86 gram. We have calculated molar mass of what? AB2. Similarly, you calculate here. Therefore, delta TF is equal to KF into WA into 1000 upon equal to Kf 5.1 into 1 into 1000 upon delta Tf 1.3 into 20. Point cancel, 0 0, 2 1 jar 250. 51 multiplied by 51 into 50 upon 30. Solve it. This will be the molar mass of what? AB4. So we have calculated molar mass. We have last part. We have to calculate atomic mass of A and B. From this molar mass, we will calculate atomic mass. Clear? Now how? Let us see. Let's solve it. Let A and B, let A and B, the atom A and B, the atomic mass. Okay, so AB2. In AB2, we can write this as A plus 2B. What is AB2? 110. Or we can write A plus 2B is equal to 110.86. Similarly, AB4, this AB4 will be equal to A plus 4B, and this A plus 4B will be equal to what? We will write this as A plus 4B is equal to 196.15. There are two equations. Minus minus minus. This is minus 2b is equal to minus. You minus it. 15 minus 6, and you will get this 2b. 196.15 minus 110.86, 85.29. This is 85.29. Minus minus cancel, you will get B. Yes or no? This is B. So B, atomic mass of B is 85.29 upon 2. What is B? Now you see B atomic mass we have got. That is coming to be 42.64. 2 4 ja 8, 42.64. Okay. Now similarly, atomic mass of A you can calculate. Putting this value in an equation, put the value of B Okay, suppose I am putting this in equation number this A, or we are getting A plus 2B is equal to 110.86. We have to calculate A. So A plus 2 into 42.64 is equal to 110.86, or we will get A plus 85.29 is equal to 110.86. So A will be equal to 25.59. Now you can see I have calculated both atomic mass of A as well as atomic mass of B. This is how this numerical is solved. Okay. Now that's all for today. The remaining numerical, that is on osmotic pressure, we will continue day after tomorrow.